We are still in Unit 3. This is lesson number 2, titled Isosceles Triangles. An isosceles triangle is a triangle that has at least two congruent sides. Remember, congruent meaning equal measures. So at least two of the sides have the same measure. The angle that is formed by these sides is called the vertex angle. The other two angles are called base angles. So if we take a look at this picture down here, all right, our vertex angle is right here. It is the angle that is formed by the two congruent sides. Now, how do we know which sides are congruent? Well, if you look at the diagram, we see these little almost lines, dash marks, tick marks, we may call them. Okay, those little lines right here, they indicate that they are congruent. So whenever you see a line like that, it's indicating it's congruent. So because those two are the congruent ones, the angle that's sandwiched in between them is called the vertex angle. The other two ones that we see down here are called our base angles. So that means that this side right here is our base. All right, so if two sides of a triangle are congruent, then we know that the angles opposite those sides are congruent as well. So if I tell you that these two sides are congruent, let me grab a different color. If these two sides are congruent, then that means that these two angles are congruent to each other as well. And if I give you two angles saying that these two angles are congruent, you can conclude that that means the two sides opposite them are congruent also. All right, so we can use that information to help us figure out side lengths and angle lengths in practice. So let's go ahead and let's start practicing identifying some angle measures. Take a look at the first example right here. Okay, we have triangle ABC, and our task is to find the missing angle measures for A and C. Well, we're only given one, and we remember that all three angles do add up to 180 degrees, but based upon the information we're given, we don't have enough to just add things up. But we do know that we have an isosceles triangle because we have these hash marks. Those two sides are congruent. So that means that this angle and this angle are congruent as well, our base angles. So this guy must be 50. Well, to find A, let's add up the two base angles and subtract from 180. 50 plus 50 is 100. 180 minus 100 is 80. Okay, so that base angle is 80. All right, let's take a look at our next diagram. Now be careful. It's the same image, but if you notice, our tick marks are on different sides. They're here and here, which means that this one and this one, those are our base angles. So if this guy down here is 40, that means this one up here is 40. To find the measure of our vertex angle, 40 plus 40 is 80. 180 minus 80 leaves me with 100 right here. Okay, now one more. We're given the vertex angle this time. We need to find these base angles. These are the base angles because they are opposite the congruent sides. So we know that these two are equal to each other. So what we can do is we can subtract out the vertex angle, 180 minus 35. That leaves us with 145. Okay, so I have 145 degrees to split between these two angles right here. So since they're congruent, I can do 145 divided by 2. And I get 72.5 as my answer. Oh no, a decimal. Ah, it's okay, folks. They are real numbers too. All right, let's flip the page, go ahead and continue on. All right, now I'm given an outside angle. Well, we did learn the other day that this outside exterior angle is congruent to the opposite two interior angles, but I don't have any information, so it's not going to help me. What I can do, though, is I can figure out this missing angle right here, okay, because these two are supplementary. They're next to each other on a straight line. They're a linear pair. So 180 minus 105 leaves me with 75 here, and I see that that is a base angle. So that means this one has to be 75. And I can add them together. I get 150. 150 subtracted from 180 leaves me with 30 up here. So if you notice, we're using all of our angle relationships to continue on. Got to know supplementary, vertical, all that good stuff. All right, take a look at our next one. Once again, I am given an outside angle. So that means this one is 75 because these two are a linear pair. Now be careful, this time I don't have the base angle, I have the vertex angle. So we're going to go ahead and subtract 75 from 180, get 105. And since these two angles are congruent, because they're base angles, I will divide it by 2. And I get 52.5 for both of those guys. And double check, add up all three angles and make sure they do indeed equal 180. All right, continuing on. Let's talk about side lengths now. So if triangle EFG is isosceles with a vertex at E, our directions are to solve for x. Clue. We don't know what any of the sides equal to, but we do know that our vertex angle is at E. That means this guy. So if that is the vertex angle, which ones are the congruent sides? It's the two that sandwich it. So they are congruent. They are equal. 3x minus 2 equals 2x plus 5, and I solve. The two congruent sides are equal to each other. I don't need the information about the third side. I don't need it. I could go back and plug it in and find that length, but it's just asking me to solve for x. So I subtract 2x. I get x minus 2 equals 5. I add 2. I get x equals 7. All right, the directions just say solve for x, but as always, I could go and plug them back in. 7 plus 3 is 10. 3 times 7 is 21 minus 2 is 19. 2 times 7 is 14 plus 5 is 19. So you can always do that as a check and make sure that these two sides really are equal since we said they should be. All right, I would like you to try the next problem on your own. Make sure you note which one is the vertex angle and decide which two sides are congruent. So please pause the video, try the next problem. When you're ready, press play. All right, go ahead, x equals 6. So my vertex angle was n. That means that these two sides were the congruent ones. They sandwich it. All right, if you got it wrong, pause the video, look at the work. If not, let's continue on. Okay, we have one last problem we're going to look at. Looking at creating an isosceles triangle on a coordinate plane. So our directions give us point A and B, and they say they are vertices of an isosceles triangle. We need to figure out the coordinates of C to make ABC isosceles. There are multiple possible answers. First thing you do, start by plotting your points. So I'm going to plot A. 1, 2, 3, 1, 2, 3, 4, 5. B, 1, 2, 3, 4, 5, 6, down 2. B is right here. And of course, you'll use a straight edge to draw your line. Okay. All right, so here's what you should do. Using a dashed light line, because we don't want to make it look like our isosceles triangle, go ahead and draw a slope step from A to B. Okay, just so I can count the distance. So it went 1, 2, 3, 4, 5, 6, 7, 7 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 this way. Okay, and there's a reason we're finding both distances. You can make A your vertex angle, or you can make B your vertex angle. It doesn't matter. If you were going to make A your vertex angle, meaning this one is in the middle, that means that AB would have to be the same length as the new line we're going to draw, and C would end up actually over here somewhere. All right, how? Well, we would have to count over. The distance from here to B is 9. So if I'm going to make A my vertex angle, I need to count 9 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, of course, that goes off my grid, so that's probably not the best choice. Okay, but if I were to plot that, I'd have a C, and it would be isosceles. So that's not going to work. So then let's try making B our vertex. So if B is the vertex in the middle, I know my C is going to end up somewhere down here. So let's count. From A to here is 7. So I'm going to count 7 more the other direction. 1, 2, 3, 4, 5, 6, 7. Okay, this one fits, so it's probably a better choice. And when I draw it, here's my isosceles triangle. B is my vertex angle because from straight down, so I went straight down, same distance to A as it is to C, making these two sides right here congruent. All right, that is it for our lesson today. Keeping in mind isosceles triangle has two congruent sides, and the angles opposite them are congruent as well.